Hello Chemistry 2 students. I just wanted to make this video to point out a few things that I think will be helpful rather than trying to put this in email, so I just created a video instead of an email. First of all, the stuff is in here that you need now, so that piece can be taken out. First thing I want to point out in today's folder, in the 19th, is that you have the bond energy data table. Bond energy data table is here. So this chart you will need to complete this assignment. And I did not provide a hard copy, I don't believe, so I apologize for that. I didn't even think about it when I was making copies. But you can use it here. We're only going to use it for this short little time, so it shouldn't be a big deal. But I do want to point out, for instance, first of all, these are organized by their groups. So anything with a hydrogen will be here, right? And then this 13 means column 13 or group 13 or 3A, right? And carbon is the 14th column or 4A. So these are the column numbers, right? So your halogens will be here, right? And so forth. Okay, so, and then there's a few noble gases down here. What I do want to point out to you, though, is that it doesn't matter how many sticks are between the two atoms. We're looking at breaking bonds and forming bonds, and then what happens when we break certain kinds of bonds overall, and the sum of those things, and what happens when we create bonds. So notice that these two nitrogens, for example, have a single stick, so that would be a single bond. And then these two nitrogens have two sticks, which is a double bond. And these two nitrogens have three sticks between them, which is a triple bond. And their numbers matter. Notice how high it is to break a triple bond, a lot harder. It's harder to break three slabs of concrete than would break two or one. Kind of think of it that way. Okay, so I want to point out that that's important. So that's the first thing I wanted to point out about the folder. If I can go back to the folder, I want to point out that the notes are now here. We're skipping example 16 just to save time, and I'm not sure where everybody was with the teaching piece of the structural formulas. Instead, I gave you the structural formulas. So listen to the notes and do examples 27 and 28, and now go along with me. Once you get that done, come over here, come back to this video, and let's look at folder for the 21st. So this folder here for the 21st, right, you're going to submit 64A, B, 65, I don't know why that says B. It should just be 65. I will fix that later. 66 and 67. But when you go into this assignment, I also provided you, so you'll see these homework in your homework packet, but to save time, instead of teaching you how to draw structures, I gave those to you in this PDF. So if I can open up this PDF and show you, so you will want to have this out along with your homework packet so that you can see what does H2 look like. It's an H bonded to an H. What does Cl2 look like? It's a Cl bonded to a Cl. What does HCl look like? It's an H bonded to a single, an H bonded to a Cl with a single bond. Okay, so all of these will be here for you to use alongside of your homework packet. So this is a nitrogen triple bonded to nitrogen, and this is 3 hydrogen single bond hydrogen. This is 2 of this entire structure, right? So remember that this 2 says I have 2 nitrogen hydrogens. I've got 3 nitrogen hydrogen bonds, right? One here, and one here. So that structure in itself has 3 nitrogen hydrogen bonds, but there's 2 of them, so there are actually 6 hydrogen nitrogen bonds. So kind of keep that in mind. I do want to go ahead and point out on 70 something important. Okay, kind of along those same lines, this is number 70, and just because I can't talk to you whenever we can, I don't get to see you necessarily every day, I want to talk about just this piece and point out some things. So this would follow suit for all the other pieces here or anything in any other problem, but I want to specifically talk about this piece right here. So what we know here in this structure, just in that structure, we have a N single bond into an N. We also have N double bonds to oxygens, and we have N single bonded to oxygen. So just looking at the structure, we know that's true. In that structure, we have one NN single bond. We have a N double bond O, and there's 2 of them, one here and one here. And then we have 2 N single bond O's right here. So that would account for all of the different bond types just in that piece. But because this 5 is out front for balancing purposes, yes, we have 1, 2, and 2, but really because of the 5, we need to multiply by 5, so that's 5. Multiply 5, that's 10. And multiply by 5, and that's 10. And then I would look up the values off of my bond energy charts. So I'd multiply 5 times whatever N single bond N is. I'd multiply 10 by whatever number N double bond O is. And I'd multiply 10 by whatever N single bond O is and get that list. That's just the math for just that first piece. you would follow that same logic for this one. Hope that helps. If it doesn't, please reach out and I'd be glad to help you. So keeping that in mind when you go through this one and others like it, I want to make sure you understand that I have for you these PDFs so that you don't have to think about what the structure pieces looks like. You should be able to use this PDF and have it open while you're working on the homework. If you have any questions, reach out via email or get on to office hours. Thank you. Have a great rest of your day.